I think it's always good to preface with that. I've had a few people come up to me and saying, "Did you not already speak? And is this your second time?" I'm like, no, that's my twin brother, and he's sitting somewhere there. Yeah. My name's Houssein Djirdeh. I'm a developer advocate on the speed team at Google, and my talk today will cover what's new in terms of what we've been working on in the past year or so to improve the speed and performance of websites. Now, one question that I get asked quite often is, why does Google invest so much time in trying to improve the speed of web pages? This is because Google has a significant interest in the web as a whole. And we know that sites are not the way they used to be 10 years ago. We're shipping a lot more than just static sites and documents. We're shipping applications that are interactive, dynamic, and complex. So to ensure that this can continue to happen, and for users to get the most benefit from every single site that they use, we also need to make sure that they stay performant enough to a point of where they're actually usable, regardless of the conditions the user might be in. There's no single way to improve speed and performance. So we've actually been applying multiple different approaches, and that this spans through multiple different teams, to ensure that progress is always happening. For one, we're improving how we provide guidance to developers. We're looking at different ways that developers can get the most insight from guides, articles, code labs, and so forth, and get this information that's relevant to their specific use case. As you'd expect, we're also working on the web platform itself. What new APIs can we release for anyone to easily use and not need to worry about building a custom solution for? We're also trying to improve the tools that developers are using to build their site, as well as tools that they use to measure how well they're actually performing. And lastly, the actual JavaScript engine that powers Chrome is always changing and improving. And it's only fair to include this in our list, even if this is something that happens behind the scenes, and you don't need to actually change anything for your site. To kick things off in this talk, let's begin by covering actual platform APIs that we've been working on to make developer lives easier. The first, and potentially the biggest one that we'll cover, revolves around lazy loading. Lazy loading is a pretty common practice that you see in a lot of websites. The idea behind lazy loading is that if there are certain assets that the user can't see until they scroll down, why not just load them right before or right when the user gets to see it? In other words, load an asset lazily instead of eagerly. For the longest time, users would take advantage of already existing browser APIs, like intersection observer or attaching event listeners, to only fetch a resource when the user has been detected to scroll to a close enough distance to it. Developers have already been rolling out their own solutions that do this, or rely on third-party libraries that they can just include to their site. But Chrome very recently released a single attribute that you can use to make this happen. And it's called the loading attribute. Here you can see an example of how it actually works. You just need to include the loading attribute to your image and specify a value of lazy. Now, the browser will automatically know to only fetch this image if a certain distance between the viewport of the device and the image is reached. So you can get the benefits of lazy loading images without doing much work at all. So like we just saw with this contrived example, the lazy value essentially allows you to defer the loading of any image on your page. But the lazy value isn't the only one that you can use. You can also use eager, to always load the image eagerly regardless of where it is on the page, which is exactly the behavior you have now if you don't include the value whatsoever. But the default behavior around lazy loading in browsers can change in the future under certain conditions. And then we also have the option to use auto, which lets the browser decide what to do. This is the same as not including the attribute at all. The big question around lazy loading is the distance needed between the bottom of the viewport and the asset itself to trigger a fetch request. You see, if we take the example of lazy loading an image, we don't want the image to load a little too late where the user can see the image loading or have to wait a short period until it does. but at the same time not have the image load a little too prematurely. Chrome doesn't let you yet modify these distances for native lazy loading, but they load them conservatively enough that it's very unlikely the user will have to wait for the image to load when they scroll down the page. The thing about these distances with regards to the native implementation is that they change depending on a number of user conditions, namely the effective connection type being the main one. Whether the user is on a 3G connection, 2G connection, 4G connection will actually change the distance lazy loaded images are fetched. So we have this awesome feature in Chrome that lets us lazy load images with a single attribute. But how do we handle lazy loading in other browsers if we decide to use this attribute, which is only currently supported in a single browser? What we can do is we can sort of take the best of both worlds. We can first try to leverage the loading attribute, and if that isn't something the browser understands, fall back to a third-party or custom attribute, or custom solution. In order for this to actually work, we need to have a way to be able to detect whether the browser supports lazy loading. And we can do this by checking to see if the loading property is present in the HTML image element interface. If it is, just rely on the loading attribute, and if it isn't, fetch a polyfill or use your own custom solution. Let's take a look at an example of how this can work. Here we have an image tag with a data source attribute, a data set source attribute, instead of the source attribute where we have the location of the image. We have the loading attribute with the value of lazy, but notice how we also have a class attribute with the value of lazy load. If we take a look at a script that can actually make this possible, again, we can check to see if the loading property is available. And if it is, we can automatically just pass in every value for every image that we want to lazy load from the dataset source to source. Now the browser will automatically know to lazy load anything that's far below the viewport, but load everything else eagerly. The reason why we're using dataset source and having a class attribute that has a value of lazy load is because there's a lot of other libraries like lazy sizes, which is a very popular one, that actually uses that pattern. It actually uses event listeners, and it has an intersection observer version where it'll actually, only when the user scrolls down to a certain distance, it'll pass the value from dataset to regular source. So by having these three different attributes, we can actually have this workaround be possible for us to leverage one or the other. The nice thing about native image lazy loading or native lazy loading in browsers is that it's not only images that are supported. We also support native lazy loading for iframes. And it works in the exact same sort of way. You only need to just add the loading attribute and have a value of lazy. If you're interested in learning more about how all of this works, highly recommend taking a look at the canonical article that we launched when the feature actually shipped in Chrome 76. Now, to talk about another browser API that also aims to provide a solution to a problem that many developers are already experiencing in their pages. And that's virtual scrolling or virtualized lists. The idea behind virtual scrolling is that if you have a significantly large list or table on your site, it can degrade performance by quite a bit. And this is because the browser has to handle such a large number of DOM nodes. Virtual scrolling helps you only render what is actually being seen by the user in the DOM, and then recycle those DOM nodes as the user scrolls. Libraries like React Window and React Virtualize have made this a little easier to do for React sites. And there are many others that let you do it for different tool chains. But the Virtual Scroller API will eventually let you do it with a very straightforward interface. And also try to provide extra capability not currently possible with many virtualized list libraries, like ensuring accessibility and allowing for find and page to work. This API hasn't been launched yet and is still under development, but it is exciting nonetheless. Now to switch gears and talk about font display. The font display property is a CSS property that allows you to control how a font face displays depending on whether it has actually finished downloading or not. Let's take a look at this example to try and understand better. If you specify swap as a value, it would ensure that the fallback font shows until the final font that you're fetching asynchronously is fetched. Notice how in the case on the left, we see a flash of invisible text if we don't specify anything with regards to font display. Now, this is from a great demo by Monica, who's also an engineer at Google, and that link there will actually take you to a pretty sweet explainer of font display with all of its possible values, not just swap. So font display has been a great way to control the loading of custom fonts in our site. But one question that a lot of people had is how can we have this functionality for fonts we fetch using Google Fonts? Google Fonts is a repository of so many custom fonts that many of us have come to rely on. As of recently, we announced that you now can by just adding a query string display parameter, which is super, super cool. If you go to Google Fonts and try to include a custom font to your site, you'll also see that this is now the default that they provide. And now this is the default that most developers will end up injecting to their site. Okay, so we've talked about what we're doing specifically to the web platform as well as other browser-level things. But now let's switch to talking about the work we've been doing on tooling to make developer lives easier. We'll begin by talking about Lighthouse. In case you haven't heard of Lighthouse, it's an open source tool built by the Chrome team that lets you measure how well your page is doing on a number of different factors: performance, accessibility, best practices, SEO, and whether it can be considered a progressive web app. The nice thing about Lighthouse is you have a few options in how you want to use it. You can open up DevTools and go to the audits panel. You can use its Chrome extension or its Node CLI. And once it finishes running a few tests on your page, it gives you a pretty handy report on how well it's doing and what you can actually improve. So Lighthouse is used by many developers around the world. And this is because it's such a nice and easy way to assess how well your site is performing. However, the one thing about Lighthouse is that the advice it provides is generalized and high level. And this makes sense. If we want to provide advice so that everyone can benefit from it, we have to make sure that they're not only specific to certain use cases. But what if there was a way to ensure that we still provide high-level advice, but supplement it with additional granular suggestions only when it's relevant? Stack Packs is a newer Lighthouse feature that makes this possible. The way Stack Packs works is every time you run Lighthouse on a page, it'll actually detect which tools are being used on your page. If it notices that a certain tool is being used, it'll actually try to supplement a certain audit suggestion or more than one with additional, more specific advice. For example, if you run Lighthouse on a page that uses WordPress, for many of the performance audits, we'll also tell you what you need to do with your WordPress admin or with your WordPress CMS tooling, so that's more specific to your actual use case. So the first version of Stack Packs launched with WordPress support. We're trying to expand this feature to include more and more tools. We're thinking of expanding to more CMS platforms like Magento, but also include JavaScript frameworks that many of us use like React and Angular. So Stack Packs, although a community-driven effort, helps provide more useful data specific to the tools you're using. What if you wanted to extend Lighthouse yourself? What if there were audits you wanted to include and maybe even share with your entire team? The Lighthouse team also launched plugin capability, allowing you to extend Lighthouse with your own custom audits as you see fit. If Lighthouse is already a tool that you use often, but it's missing an audit or more that you would personally love to see that's relevant to you, you can actually do that now. Here's an example of a Lighthouse plugin that was actually built by Trio, a page speed monitoring company. One thing we have in Chrome is something called the Chrome User Experience Report, which allows us to assess real user performance metrics that actual Chrome users are experiencing. They created this plugin to supplement Lighthouse with this information, and they've even added their own scoring grade for it. Notice how it shows an entirely new Lighthouse section, which is pretty neat. Another thing the Lighthouse team has been thinking of is, what if Lighthouse could also let you set budgets? The idea behind budgets, or performance budgets, a lot of developers tend to do this to set limits to a lot of the things that affect performance on their site. And the reason why they do this is because when you're building an application and code is being added and removed and it's changing, it's always good to know if your application fits a certain threshold. If it passes that threshold, you'd most likely want to get to know, either through a warning or a build error or any of that sort. So because a lot of people use Lighthouse in their day-to-day tool chain, a colleague of mine, Katie, actually started working on something called Light Wallet. And it actually integrates budgets directly into Lighthouse. You only need to define a single budgets JSON file, and then you can actually define a limit on script size or script number for both your first and third-party scripts. If those numbers are exceeded, you'll actually have Lighthouse flag them and let you know. So Lighthouse is great, and I'm so happy to see we're making it better for the many people that use it. But what about the different type of tooling? The tooling that developers use to build their sites every day, like client-side frameworks. So one thing I've been doing is I've been trying to use something called HTTP Archive to try and figure out how many sites that are using a certain framework and how well they're performing wholesale. For those of you who haven't heard of HTTP Archive, it's an open source attempt to track how the web is built. It crawls millions of URLs every month and then passes them through web page test, storing key information about them. Paul Caldano actually has a great talk about it, and most likely, I think he's talking about it tomorrow. So if you're interested in HTTP Archive, highly suggest actually attending that talk. But the reason why I found it super useful is I was trying to see how well sites that use one or more of these frameworks are generally performing. And one thing I found out was, after querying over 250,000 origins that use either Angular, React, or Vue, I noticed that 50% of them ship over a megabyte of JavaScript. Now, this is compressed and minified. So it's a lot of code to be shipping to your users. One thing in Chrome we've realized is that a lot of developers that rely on these frameworks are not realizing that they're pulling in dependencies and bloating their application up and not having the checks that they need for it. So we're trying to work with framework authors to make this even better. We're collaborating with Next.js, a meta framework over React. We're communicating with React authors, and we're also talking with the Angular team to see if we can build a tool chain that they're currently using. Also, I'm going to fix my mic. Here we go. Now let's switch gears one more time and talk about some of the guidance efforts we've been working on. If you've looked at any of the guidance we provide at Google, you'll notice that we provide quite extensive guidance on improving performance, reliability, and many other factors of your site. But one thing we're also trying to do is we're trying to make sure this guidance is more nuanced and more specific to you as a developer, depending on what tools you're using. So we're trying to combine both our guidance with our tooling like Lighthouse. Web.dev is a new thing we launched about a year ago that actually does this. The idea behind Web.dev is if you go on it and decide to actually test your site, it'll run Lighthouse under the hood. For things that it noticed that you can improve on, it'll actually point you to resources that we've written that are relevant to you. One thing in particular in Web.dev that I quite enjoy doing, and I'm actually leading, is its frameworks efforts. And the thing about frameworks is there's a lot of guidance out there that tell you how to build something using a framework. Like how to build something using React, how to build something using Angular. But there's not much out there to tell you how to build a performance site using a specific framework. So we currently have guides on React and Angular that currently do this, and we're planning to add a lot more. Next.js, other meta frameworks like Nuxt, as well as having Vue and other smaller frameworks. The last factor that we can't really ignore, even if it's something that happens under the hood that you don't need to concern yourself with, are optimizations directly baked into the JavaScript engine within Chrome itself, V8. To talk about one example of an optimization that was recently added, JSON as a format is so commonly used in many applications today. You can think of one such widely used use case as the global data stores that many developers rely on in their applications. For example, a Redux store. Instead of using a regular object literal, you can always represent it in string form and parse it at runtime. Although that might look a little more unusual, every major JavaScript engine will always parse, compile, and execute the second option here faster than the first if the string is evaluated once. The amazing thing about the JSON parser, however, is that the V8 team has made it significantly faster at scanning and parsing JSON. Here you can see a chart of how much of a speed improvement parsing has become on a number of different sites, some up to 2.7 times. If you're interested in this type of optimization and all the other optimizations the V8 team has been doing, such as script streaming and so forth, highly suggest reading this article, who's written by Adi Osmani, an engineering manager on the Chrome team. And it dives into a lot of these optimizations and explains why they matter. So we've talked about different factors and how we, in Google, are trying to improve performance in more than just one way. But I sort of want to finish this talk talking about the performance problem. You see, I focus on performance and speed. And as a developer advocate, most of my work usually involves doing a lot of external type-facing work, such as writing blogs, building third-party libraries that you can pull into your site, giving talks like the one I'm giving right now that tell developers how to build faster sites. But a lot of the things we've talked about today are actually on the other side of things. More internal, improved tooling, better browser defaults, things that as a developer you might not want to take care of and would probably like the tools you're using to take care of it on their own. The issue, I think, with a lot of the things we do with regards to performance is it can sometimes feel we're doing a lot more of the external-facing work. And eventually, I'd like to see the shift on the other side. In an ideal world, we, as advocates, wouldn't need to tell developers what you need to do to improve the performance of your site if the tools that you're using are already doing it by default. A lot of the efforts we talked about today are about that type of internal work. So I'm excited to see where we end up in the next few years. I hope you enjoyed this talk. I think we have time for Q&A. My name's Houssein. Thank you.